Hello. Uh, Hi, everyone. My name is Alen Ladavac. I am CTO at Croteam. Croteam is one of the oldest and biggest today Croatian game development studios. We started making games way back in the 90s on the Amiga platform. Later moved on to PC, and we made a Serious Sam series, which has huge number of games across many different platforms, and lately Talos Principle, and also created several VR titles. And I mentioned that we started on Amiga because we had experience back then in the 16-bit era, and it relates to the topic of today's talk. It's about frame pacing or display timing. There's various terms for various things, and there's a lot of confusion around this whole topic, and I would like to touch many of those things. I titled this talk pre-sequel to the infamous Elusive frame timing. It's quite a mouthful. Elusive frame timing is a talk I gave at the last GDC, which is where we finally publicized something that we've been researching into for more than 10 years, 15 years almost. But that's been, it's been quite a fight against windmills in terms that we've first seen this thing way back in, I think, 2003, which is a problem. It first manifested itself as case where you literally have an empty level, yet the game stutters. It seems that it's not hitting 60 frames per second. And this is where our research started. I'm going to talk a little bit later about how that went and what's been happening in the recent times. But let's first, before I start anything, because I'm going to be showing you different examples of stuttering, I have to make sure that we can actually display 16 frames per second. And I've been giving talks about this for some time, and every time there's always a potential that we cannot even show that on the display. We've been testing it here. But first, let's see if we can get 60 frames per second here. So yeah, this is quite right. Sometimes because of Windows or something, there's going to be some stutter. But basically, this is a 60 frames per second straight video. And even the video players have the same problem that we experience in games, and that users very often misinterpret as game performance problem. But so for comparison, I'm going to show you something that people usually call stutter lately, or often bad frame rate or something. So it looks like this. I guess you see that it's not quite as smooth as you would like it to be. Now, when people see something like this, they have various interpretations of the problem. Let's say the game is laggy, maybe they say it has bad frame pacing, or it's micro-stutter. Some of those things have some background, and some of that is partially true, but it's very often misunderstood, misinterpreted. Or just say the game sucks, or the driver sucks, or some people recommend that you should get the 144 Hz monitor and that will solve all your problem. Or you need a G-Sync and that will solve everything, which is like a completely different topic, and there's a lot of confusion about that as well. Or your GPU is too weak, you need a better GPU. You need a bigger PSU, that's what I heard, there's power supply. Or people say that you need high purity oxygen-free bare copper wire with 24 gold-plated contacts, and then everything is going to be smooth. Which is complete nonsense. All of that is, most of that is complete nonsense, most of the other arguments. So basically, a lot of those things are just what people say. What they actually think is either that it's not fast enough, or that it's not running at constant speed. The question is it really always the case? Sometimes it is, sometimes it's not. I'm going to cover different cases. So, I also want to touch on the different topics, like especially if you're like an indie developer or something, so you're using maybe Unity or Unreal, or even if you have your own engine. Even if you use Unity or Unreal, which do cover parts of the frame pacing and things, you have to be aware about how those things work to be able to interpret what's happening. There's a really nice article by Glenn Fiedler, been done a long time ago. It's still, all of that still stands, and all of the games use some of those techniques. So basic approaches is like, if you're lucky enough that you can guarantee that for all the target hardware you're going to be running at 60 frames per second with very large margin, then everything is going to be fine. You usually won't notice any problems. If you have to account for the fact that at some point you're going to have to drop to 30, maybe some people have slower machines, maybe some scenes are more complex than the others, then you have to adapt your framing between 30 or 60 frames per second and other things, and that's when it gets complicated. Now, on the base level, you have to cover, either you have fixed substeps, so you always run at 60 and you drop to 30, then you run the same frame twice, or you can have semi-fixed substeps depending on, you can run 100 hertz and run several steps per frame, then interpolate. There's different things that can be done here. In this respect, it's important that you know, for example, in Unity, there's update versus fixed update, where one of that handles per frame, one of that handles per step, and you should research into that to make sure that first, that your game's handling of actual simulation steps versus rendering steps is correct. But once that is true, there's still a lot of other things that can go wrong. Now, basically the game simulation loop is doing what you see at the top part here. It's running a loop. First, it does physical simulation to move the objects for the next frame, then it renders the next frame, and then it calculates what the actual step should be for the successive frame. Or if we go deeper into this, at first line, can I use this? No, it doesn't point anyway. So at the first line in the lower part here, you say position equals position plus velocity times frame step. This is the simplest example of what we actually do in simulation. We move objects by constant velocity, for example. Depending on the frame step, if you run at 30 frames per second, you're going to have to move objects in larger steps. Then you render, and then how do you actually calculate the frame duration? This is one thing that's very tricky. So basically, the way to think about it is that as you're running through the frames, the difference in some timer between the current time and the time that was at the same position in the frame loop in the previous frame, that's your frame length. It makes sense. But it's actually not that simple. We'll see about it later. So we're going to run some little double-blind tests. It's not actually a double-blind and you see a lot of things there, but just look at how these frames, how the smoothness looks in these examples. So first we have sample A. So it's see what you think about that. And then we have sample B. And finally sample C. So I don't know what you think, but I think the last one actually appears the smoothest. And it goes contrary to what people usually say, like the game needs to be faster. Because it's a little bit, it shows the results down there in the frame graph. The first one is actually the fastest. And it looks pretty bad, because it's fast and then it stutters a little bit every few frames. The second one stutters much more, it looks a little bit smoother even. And this one is running at exactly 30 frames per second and it looks much better. So faster is not always better. There's a lot of things that human visual system interprets as smooth, so it can interpret smooth 30 frames per second as better than 60 that sometimes stutters. So I have some very interesting ways to show this. So here you have 3 of those white spheres, and they run at different frame rates. So this displays 60, and the top sphere is a reference sphere that runs is exactly 60 frames per second. The bottom one is 30, the one in the middle is switching between 30 and 60 every once in a while. And you see how the bottom one, it's not as good as the top one, but it's definitely much better than the one in the middle. Now people usually say like, yeah, this is because you run 30 for a few frames, then you run 60 for a few frames. If you knew that you're going to do something like that, maybe you could interpolate all that and run for a continuous, I don't know, 45, 50, whatever your actual performance is. And we also, when we were researching this particular case a few years ago, we also thought that that would be the case, but this is a very nice syntactic test where I can do various experiments, and you can see that that actually looks even worse, because your eye doesn't want to see this difference between frames. So I think we can kind of like conclude that it's better to run a smooth 30 than to try to match 50 in any way that might seem possible, but doesn't actually look good. So what we identified so far, performance, which is something I didn't really show. I mean, everybody knows if it's really, if it's faster and it runs at 60s, of course it's going to be better than 30. But then again, you have this consistency thing that I've shown, that you should pick some multiple of refresh rate at 30 or 60 and be consistent with it, and that looks much better. So if it is optimized and it always runs at exactly 60 frames per second, so every time the new refresh comes, your game is ready with a new frame and displays that frame on time, it's going to always look perfect. That's the theory, and that's what everyone's been thinking. But there's a huge caveat there, and this is the caveat that we ran into around 2003, and we were not aware that this is the problem. When we made Serious Sam 2, we noticed this during development. We tried to hunt this bug down. Like, it looks like 60. There's no way that we could be misperforming with such a simple scene, yet it stutters sometimes. But then again, you reboot the machine, or you run some other application, come back to the game, suddenly everything is okay. Then 2 hours later, again, it's not okay. Happens to some people, doesn't happen to some other people. And we shipped the game in the end thinking that we have some bug. Over the years, I've been seeing the similar problem in other games that I've been playing. I've been seeing people on forums or for our games and for other games mention things like that. Like someone says, like, he has a very good machine, still the game stutters. Then the next day, everything is okay. It was a huge mystery. And we actually happened to run into a case that we were able to consistently reproduce. It was back 2013. When we realized what was the actual cause of this problem. I'm going to demonstrate a few things here. So, yeah, I missed this slide. So, this problem is very hard to catch. It looks like this. It looks like this heartbeat graph there. So, see, in average, you're running at 60, but it looks like it jitters around 60. And consistently reproducing this is as hard as catching a Yeti. So, it looks like this. This is actually the first example that I've shown as a stutter. But what I'm trying to say, you see those skips. But what if I told you that this is actually 60 frames per second? There's no skipping there, even though you saw skipping. Now, compare the top is smooth 60 and the bottom is cut from this previous video. The bottom stutters. The top doesn't stutter. But it's not skipping the frames. The top and the bottom are running at the same frame rate. Now look at this slowed down. Every time the top has a new frame, bottom also has a new frame. So this game is actually generating 60 frames per second, and it's not smooth. Now, how did it happen? If we take I took a sequence of slides, but if you look a little bit look at this column, how it splits in the middle. So I took a few sequence of few of those frames, and look at this. The first 2 frames, this tree is completely continuous. There is no breaking, and both of those frames lasted for 16 milliseconds. Now in the 3rd frame, you can see that the tree has broken apart, and this frame lasted for 24 milliseconds. So this frame was slower, right? It wasn't 60 frames per second, but when you think about it, this frame was slower, but the tree actually went ahead. It's not intuitive at the first look, but it actually completely makes sense, because if frame rate is lower, then you have to run your physics for a larger time step, so the objects are going to move faster. But what actually happens is you are still displaying 60 frames per second, and if you do this, you run faster and slower physics while you're actually displaying 60 frames per second, then of course it's going to look like stutter. The question is, why are we measuring 24 here, and then we're measuring 10? And you go 14, you go 17, so in average we're running 60 here. But it's not just in average, because we actually generated each of those frames on time to be displayed on the screen. So the stutter happens because the game doesn't actually know how fast it was displaying. What is shown, that simple pseudocode that I shown before, it said that we should subtract the current value of the timer from the value of the timer at the previous frame. But which timer? The only timer that actually makes sense is the display timer on the monitor. Was the frame actually displayed or not? The fact is that this is quite an oversight on the side of the APIs for the past like maybe 20 years. When we used to work on older platforms like the Amiga or older 8-bit, 16-bit computers and consoles, we also always had the complete control over when the frame actually happens. And now with the GPUs that are deeply buffered and asynchronous to the CPU, most of the games are still just measuring the time on the CPU, which doesn't always correspond to when the frame was actually shown. And in most of the APIs, especially on the PC, there's no way to actually tell what's happening. Now, look at this. This is this stutter, and this is the experiment that we use to prove that this is the problem. So we change a little hidden variable in the game, and now suddenly it looks, everything is smooth, but look at the graph. It's actually still measuring the same, but it's smooth now. So the question is, what did I change to make it go smooth? I changed a debug variable that we usually use this if we want to, like, we want to bake some movie, and usually if you want to take a screenshot of every frame in the game, it's going to take a lot of time, so we just turn off completely the timing for the game. Let's say the game, let's pretend that this is 60 frames per second, and no matter how long it takes to render the next frame, always run the physics as 60. So when we were able to consistently reproduce this, we just went in, and we changed this on the same scene, and suddenly it was running fast. That's how we were able to first prove that this is only about timing. So if you remove the actual time measurement from the equation, the game is running smooth. And that's because it was always running smooth. It was just calculating the simulation in the wrong way because it was timing it wrong. Now, at the moment, there's not really an API in most of the platforms that would allow us to fix this. We were able to pinpoint this issue and do this experiment in 2013. Then we started going to IHVs, to NVIDIA, AMD, talking with Microsoft. In the end, we've been talking at the Vulkan advisory panel, talking to the Vulkan board, and tried to get some extension into Vulkan. And this is something that is still in the process of being implemented in the Vulkan API, which is where it's probably going to happen first. And it turns out that it's actually quite complicated to implement something like this today, even for the drivers. Especially on Windows, for example, one of the problems that you have is that there's a compositor that comes after the game. So whatever the game does, Windows takes over at the end of the frame, and they actually choose when to display that frame and when not to do. It of course depends on whether you're full screen, not full screen, whatever, but it's not even that easy for IHVs to just directly implement this. But we're working with them, and we're trying to have them fix that in the future APIs. Again, I have to stress that if you can guarantee that you can run at 60 FPS, and if you're not measuring, you will not have this problem. Then again, if you have a large enough leeway between the end of your rendering and the actual display, so you don't actually need 60 milliseconds. If you're running like a very simple 2D game and you can run at 10 milliseconds, then you lock the frame rate to 60 milliseconds, you're not going to see this problem probably in any case. So if you have bad performance, of course, you should optimize. Then you should make sure that you don't show uneven, quickly changing frame rate. So if you notice that in one frame you've dropped from 60 to 30, you should try to keep it. This is, again, one thing that is not possible in many APIs. There's this thing, present after minimum duration that's available on Metal, for example, that can guarantee that the driver is not going to display your frame too early. Because once you start dropping to 30, your physics keeps preparing the next frame to 30, but once the user is going to run into some scene that is faster, and you're not going to anticipate that, and you're going to display that frame at 60, whereas your physics was calculated for 30. And that's where you get a stutter again. So, yeah, if you try to fix the quickly changing frame rate, you have to make sure you don't attempt to run at not factor frame rate. So you don't try to run at 50 FPS if the monitor is actually at 60 Hertz. Again, it can be hard to do if your API doesn't allow you to actually tell the API how long you want the frame to last. And lastly, incorrect timing is something that is still very hard to achieve on many platforms. You can try to do some workarounds. Like, for example, first thing that we did was just like average the time over several frames, which makes this problem less prominent, but it still exists in a way. I think that I'm running really short on this one. Thank you for your attention. Do you have any questions? Yes?
Testing?
So just a really quick question. Do you actually know of any situation where a game would actually have a fixed frame rate? Like modern games usually have a variable time step. I can't think of any situation where a fixed time step would be actually used, unless it's maybe an arcade machine that's on that specific, working on one specific hardware. Something maybe like a fighting game.
I think that in 3D games, especially lately, there's no way you can do that. You have to go for fixed time rate. But in some very extreme examples, I haven't really researched deeply into this, but I would expect, for example, I don't know, Super Meat Boy that doesn't even try to cover running at 30. You wouldn't actually be able to play such a game. So you can like say, okay, it's 60. If it's not 60, it's going to slow down the time. It's going to be broken. But then you won't expect to have this kind of problem. But if you have to, in most cases, you have to do what you say. And then you're going to have this problem. You have to try to cope with it. And we can hope that very soon we're going to have the APIs to actually cover this. There's really nice process that could be able to completely counter this problem. And we're working on that with the API vendors and trying to make that available to everyone as soon as possible.
Hello, you mentioned that you also worked on VR game. I was wondering if you also have looked into that issue specifically for a VR headset, because I assume it would be even worse there for the players.
Yeah, VR is a completely different thing, and this issue per se does not really exist there. There's no compositor, and the timing itself is done completely different. You can also see that usually you don't see these problems on consoles. Again, because the entire stack about how the kernel and driver and everything operates on there, this kind of problems does not appear. For example, on consoles you usually have like, you have fixed, you have the frame timing for each frame is fixed, and the OS is reserving something for the compositor. Usually if you can have an overlay when you press you know, this home button on an Xbox or something, then they reserve that time, and they don't vary that, and they don't, as far as I know, they don't throttle the GPU up and down. For example, on PC, a lot of these problems are caused sometimes by the GPU throttling or things like that. So, no more questions? Okay, thank you, everyone.